Assalamualaikum warahmatullahi wabarakatuh. My name is Hashwi Hauli Ramadan. My number is student 2024-32071. Here I want explain about my assignment, the machine learning practical. Today I'm going to guide you through my implementation of the naive Bayes classification algorithm using Python and a Jupyter Notebook environment. The main objective of this practicum is to build a predictive model that can classify participants into their respective training groups based on the heat versus hypertrophy gains dataset. Okay, first one I want to explain about importing the required libraries. Starting with cell number 1, this block is dedicated to preparing our development environment by importing all the necessary libraries. First, we import pandas SPD, which is an essential library for data manipulation and analysis, allowing us to handle data structure like data frames. Next, we bring in NumPy as NP to support large, multidimensional arrays and high-level mathematical functions. For the data visualization phase, we import matplotlib.pyplot as PLT and Seaborn as SNS. These plotting libraries will help us generate clear and informative visual representations of our model's evaluations metrics as the end of the script. Okay, cell number 2, data loading and initial cleaning. Moving on to cell number 2, we perform data acquisitions and initial data cleaning. We load our dataset by reading the CSV file named heat versus hypertrophy gains CSV using the pd.read _CSV functions, and we store it in a variable named df. Right after loading the data, it is critical to evaluate the relevance of each features. Here, we notice a column named participant _ID. Science and identification number is purely unique to each individual and holds no mathematical or predictive value for a machine learning model. We drop it from our data frame using the drop method with axis equal 1. Finally, we call display df.head to inspect the first 5 rows of our cleaned dataset, ensuring that the remaining columns are structured properly. Okay, we move to the cell number 3, preprocessing with label encoding. Let's refer to cell number 3, which handles an essential preprocessing task. Machine learning algorithm, including scikit-learn's naive Bayes implementations, operate on numerical values and cannot process raw categorical text directly. In our dataset, features like gender and dietary conditions contain text data. To fix this, we use a list comprehensions to identify all categorical features that have an object data type. Then we import and initialize the label encoder tool from the scikit-learn preprocessing module. By running a for loop, we apply fit _transform to convert this textual categorical into discrete numerical representations, such as 0, 1, and 2. Displaying the head of the data frame again confirm that our entire dataset has been successfully converted into a fully numerical format. Okay, we move to the cell number 4, splitting features and target. Now, let us look at the cell number 4. In this step, we establish the foundation for our training process by separating our dataset into independent variable and independent variable. We define our features matrix represented by capital X by dropping the group columns. This means X contains all the physical and experimental attributes for the participant such as age, gender, fat, percentage, and dietary conditions. On the other hand, we define our target vector represented by lowercase y, which isolates the groups columns. This groups columns is our target label that the naive Bayes algorithm will try to learn and predict. Okay, next I want to explain the cell number 6, the train test split. In cell number 6, we partition our data to prepare for model validations. It is a golden rule in machine learning never to test a model on the exact same data it used during training. Therefore, we utilize the train test split functions. We apply a specific ratio of 75 to 25. This means 75% of our data is allocated to X-train and Y-train for building the model's knowledge, while 25% is set aside as X-test and Y-test to act as completely unseen data for testing. We also set the random state parameter to 0. This ensures that the random shuffling is reproducible, meaning anyone running this code will get the exact same split. Okay, cell number 7 is model training with Gaussian naive Bayes. We initial and train our classifier. We import Gaussian NB from the sklearn.naive Bayes module. We select the Gaussian variant because our dataset consists heavily of continuous numerical variables, such as body mass, fat percentage, and physiological change, which are assumed to follow a normal distributions. We train our training subsets once the model learns the conditional probabilities from the training phase. We generate predictions for both our training features and testing features, saving them into YPRED-train and YPRED-test respectively. Next, the cell number 8, evaluation and visualizations. I want to explain the two cells, okay, which focus on comprehensive model evaluations. We generate a classifying report and confusion matrix for both the training and testing datasets. The classification report gives us three crucial metrics: precision, recall, and the F1 score. Precision measures the accuracy of our positive predictions, meaning out of all samples predicted to be in a certain exercise group, how many actually belong to it. Recall measures the sensitivity, meaning out of all real members of a group. How many did the model successfully find? The F1 score represent the harmonic mean of precision and recall, serving as a balanced measure of overall performance. To make this result intuitive, we plot a confusion matrix heat map using Seaborn. The dark diagonal box represent correct classification, while the off diagonal cells show us exactly where the model made errors or misclassifications. Okay, thanks. That's my explanations. Assalamualaikum warahmatullahi wabarakatuh.